Hello, in this video we are going to study the system of equations and specifically linear homogeneous system of differential equations with constant coefficients. An nth order linear system of differential equation with constant coefficients is written as dx by dt xi prime is equal to going to all the way till n phi of t where I belongs to n. And here if we observe x1t x2t up until xn of t are unknown functions of t, a I j are certain constant coefficients which can be real or complex, f I d are given functions of variable t, and we assume all these functions are continuous on the interval a b of the real number axis t, and by setting we get xt has x1 of t, x2 of t, all the way till xn of t, and x prime, the derivatives of them would be xn prime of t, and f of t's would be f1, f2, all the way till fn, and a, the coefficient matrix will be this is the system of differential equation in the matrix form, which is written as x prime of t as a xt plus ft, and when ft is identically equal to 0, or that is ft is 0, then the system is said to be homogeneous, that is x prime t is a x of t. And homogeneous system of equation of with constant methods can be solved in multiple ways. Here we are specifically I'm considering the elimination method. So let us consider a homogeneous system of equation with constant coefficients. x1 prime has a 1 1 x1 plus a1 to x2, and x1 to x2 prime would be a2 1 x1 plus a2 to x2, and let this be 1 and this be 2. Let's differentiate equation 1 and then substitute the value of x2 prime in 1. So by differentiating 1 we would get a11 x1 prime plus a12 x2 prime, and utilizing the value from 2, this would become rearranging let this be 3, and from 1 if we take the value of a12 and x2, that would be x1 prime minus a11x in the equation 3, we get a second order linear homogeneous equation, that is a11 x1 prime x1 prime minus a11 x1, and Rearranging the term. And sending everything to the left. So now we obtain the second order linear homogeneous equation, and it is easy to construct a solution if we know the roots of the characteristic equation has lambda square has a11 a22 lambda plus a11 a22 1 is equal to 0. In this case, the real coefficients a1j, that is a11 or a22, a12, a22, can be real and complex. And in particular, if the coefficients a12 and a21 have the same sign, then the discriminant of the characteristic equation will always be positive, and therefore the roots will be real and distinct. And after x1 t is determined, the other function next to t can be determined from the first equation. A note, elimination method can be applied not only to homogeneous linear systems, but it is also can be used to solve non-homogeneous system of differential equations with variable coefficients. Thank you.